Hello everyone. So we will discuss the week 4 assignment 4 of database management system. So for question number 1, we have been given a relation online race with the attributes game ID, player, car type, car color, race time and laps, and we have to find the highest normal form of online race. So we have been generated the following functional dependencies. Like for the game ID, it is player, car type, car color, race time, laps, and the rest are as follows. So here the candidate key is the game ID. So as there are no partial dependencies, so it is in second normal form, and additionally there is no transitive dependency. So it is in third normal form. It is in not in BCNF because for to be in BCNF, the left hand side attribute all the functional dependencies should be a super key, which is not here in this case. So for question 1, C is the answer. Now coming to the next question, we have been given the relation delivery with the following attributes and the following functional dependencies, and we have to find the canonical cover of the for the functional dependencies. So the solution for it is as follows. First, we have splitted the functional dependencies using Armstrong axioms of decomposition rule. So here the dependencies are splitted as follows, and now I have numbered it as 1, 2, 3, and 4. And next we have find the closure of the left side of the attributes. First, by using the including the attribute, and for the second time it is excluded, and we see if there is any difference in the result or not. If the result is same, like in the same, then we can ignore the dependency. So in the first case we can see that these two are uh, the two results are different, so we cannot ignore it, so we have included. Similarly for the second, third, and fourth we have done. So resultant functional dependency we get is as follows. Now since the INCS, here INCS is for IN is for item number, and C is for charge, D is for destination, and S is for speed. So coming to the next point, um, where now since the left side has more than one attribute, so we have again split it in the closure and have find if they all are giving the equivalent result or not. So by splitting the INC and S, finding the closure and splitting each of these, we find that they are not equivalent, therefore that is included in the functional dependency. And next, when we find the for CD, the closure for CD, we get the following, and we have see that CD closure and D closure is same, so we ignore the C closure and we get the following. So here the canonical cover for this is option B. So for question 2, B is the answer. Since I have not done the third question, if anyone has done, please let me know in the comment section. For question number 4, C and D is the answer. For question number 5, we have been given the relation T, and which has the following attribute: MFT, origin, type, flavor, and rating, and we have been given the following functional dependencies, and we have to find the maximum number of candidate key for the relation T. So here are the I've written the functional dependencies in one line, like MFT, it's find out the origin and time, and similarly for the others functional dependency I've written this, and find the closure. So MFD plus origin type closure, type flavor closure, and waiting closure. So this all can identify the whole attributes. So there are four candidate key for this relation T. So for question number 5, C is the answer, which is 4. For question number 6, we have been given the relational schema investor with the attributes investment number, amount, and tenure. And we have been given two different sets of functional dependencies for investor. First is organization A and the second one is organization B. And we have to identify which of the following statement is true. So for organization A, the functional dependencies follows this, and for organization B, the functional dependencies is as follows. So what we have done is we have find the closure of the attribute of organization A by using organization B. Like for organization A, IN closure, we have used organization B. Like for IN plus, we can find IN, that is investment, AMT is for amount, and T is for tenure. So in the by using organization B, for investment we get amount, and then for amount we will get tenure. So we have done similarly the rest of the following closure, and what we see here is that organization A is a subset of organization B, and similarly in this the organization B is a subset of organization A. Therefore organization A is equivalent to organization B. So for question 6, C is the answer. Now for the next question, we have been given the relation pollution control, which has the following attributes: factory ID, emission level, emission effect, and locality, with the following functional dependencies FD1, FD2, and the pollution control is decomposed into two following relation, which is pollution control 1, which have the attribute factory ID, emission level, emission effect, and pollution control 2, which have the attributes factory ID, emission level, and locality, and we have to identify the correct statement. So first, for finding if the relation is lossy or lossless, we have to satisfy certain condition. The first condition is that the attribute of the relation which is splitted, like here in this case pollution control 1 and pollution control 2, I have written it in short form PC1 and PC2, and the attributes ID is for factory ID, EL is for emission level, and EE is for emission effect, and L is for locality. So I've checked the following condition. First, the attribute of PC1 union the attribute of PC2 should give the whole relation, that is attribute of PC, that is pollution control. So first condition is satisfied, we get all the attributes. Now for the second, we have to find the intersection, and it should not be null. So here it is ID and EL, that is emission effect and factory ID, it is not null. So second condition is also satisfied. But for the third condition, which says that whichever the common attribute which comes, it should be a key of either the splitted relation 1 or 2. That means for our case, and the attribute which we get in common should be a key of either PC1 or PC2. But here we can see that ID and EL, that is factory ID and emission level, is not a key of either PC1 or PC2, that is pollution control 1 or pollution control 2. Therefore this decomposition is not lossless, and neither dependency preserving, because for uh, dependency preserving, none of the functional dependencies are the part of the splitted relation, that is pollution control 1 or pollution control 2. Therefore for question 7, D is the answer. For the next question number 8, we have been given the relation machine parts, which has the part number, machine number, color, shape, and position attributes, and we have been given the following functional dependencies, and we have to find the attributes which are present in both in closure of position and machine number. So first let's find the closure of both position and machine number. So here uh, PN is for part number, MN is for machine number, C is for color, S is for shape, and PO is for position. So I have represented the functional dependencies in the one line, that is for PN is finding MN and C, that is machine number and color. And similarly for the rest of the functional dependencies, you can see it here. So I have finding the closure of the position, we get PO, PN, MN, C, and S, and finding the closure of the MN machine number, which is MN, we get MN and S. So we have to identify which are common in the both. So we can see that MN and S both are common, but in our option we have been given only the position. So wait, yeah, the common is S, which is shape. So for this question 8, sorry, it was right, C. For question 8, C is the answer. And question 9 is the continuation of the previous question, and we have to find which is not a candidate key. So for finding which is not a candidate key, we simply find the closure of the machine number and shape. So we get only the machine number and shape. So as we know, for being a candidate key, it should identify all the attributes, so it is not identifying it. So for question number 9, C is the answer. Question number 10, we have been given the instance photo book, which has the attribute page, photo type, camera, and subject number, and we have been given the following table, and we have to tell which of the functional dependencies do not hold on photo book. So subject number and photo type does not hold, because consider the subject number 1 and photo type wildlife. So for this 1 and wildlife, we get the page as 1, the page, and camera as Canon. But similarly for the subject number 1 and wildlife, we get different which page, which is 2, and camera is Nikon. So we are saying that for the same subject number and photo type, we are getting different pages and cameras. So for 10, option D is the answer. So if anyone has any different answer, please comment down in the comment section, and if any changes in the answers are made, I will pin in the comment section. So before final submission of the assignment, do check the comment section, because if any changes, necessary changes is can be there, so I will pin it in the comment section. Like similarly for the week 2, there were some changes in the answer, as many of you commented and told that these changes could be made. So I have done it and I have pinned. So before the final submission, please once check the comment section. Okay, so thanks for watching.